In this lesson, we will learn how to find the value of trig functions for special angles. Now, here's what I mean by special angles. Remember special triangles? We learned special relationships when you have a 45, 45, 90 triangle and it was like this, or if we had a 30, 60, 90 triangle, then the relationships were like this. So the special angles that I'm talking about are 30 degrees, 60 degrees, 45 degrees, and actually even 90 degrees. All right, so all of the angles shown in this picture, this is what I'm calling special angles. Now, this is a unit circle. It's a unit circle because the radius is 1. So that's 1 in all directions, including the hypotenuse of this triangle is going to be 1 because that's also the radius. Now, the unit circle is very useful. In this lesson, we're going to be working with radians instead of degrees. So we have learned that a semicircle, all right, halfway around to here is pi. Okay, so if I went like that, that is 180 degrees, but in radians it is pi. And similarly, that means up here will be half of pi, or pi over 2. Now, if I stopped right here at what we used to call 45 degrees, but now we're going to call it pi over 4. Okay, so this angle is pi over 4 because it is 1/4 of the way around. Or you could take this semicircle and look at it as being divided into 1, 2, 3, 4 pieces. So this is 1/4 of pi, so pi over 4. Alright, so remember that this is the same thing as 45 degrees. So I'm just mentioning that so we can use our knowledge of a 45, 45, 90 triangle. And don't forget that the hypotenuse is 1. Now our goal is to figure out what is the sine of pi over 4 and the cosine of pi over 4 and what's the tangent of pi over 4. That's our goal right now. So to do that, it would be helpful to know the sides of this triangle. But we can use our special triangle knowledge. If this is 1, and then the way our pattern went, that we used to know, it went like this. It was like, if this was n, this would be n, and then this would be n radical 2. So, looking at this, alright, n radical 2 must equal 1. Alright, I'm just going to do that off to the side. Alright, since we know this is 1, then n radical 2, n radical 2 must equal that 1. So I would divide both sides by radical 2. Okay, so that's going to give me that n is 1 over radical 2. Now, if you rationalize the denominator, that's the same thing as radical 2 over 2. I'm going to use the 1 over radical 2 version. Okay, so we just found that these two sides are both 1 over radical 2. Now, so focus on this angle right here, all right, the reference angle, and we want to find the sine, cosine, and tangent of that angle. All right, that's the goal of this video. The sine function is opposite leg over the hypotenuse. Since the hypotenuse is 1, it'll just be this, all right, 1 over radical 2. Similarly, cosine is adjacent leg over the hypotenuse. And again, since the hypotenuse is 1, then the cosine will just be 1 over radical 2. Now, tangent is defined as opposite over adjacent. So, since these are both the same thing, anything divided by itself is just going to be 1. So those are the trig functions. Now, before I go on to the reciprocal trig functions, let me just mention as a side note, we are often interested in the coordinates. Hold on. Let me use a different color. I'll try green. We are often interested in the coordinates of various points on the unit circle. So please understand that we have also just found the coordinates of this point if we needed them. The coordinates would be 1 over radical 2 because that's the horizontal length here. And since the vertical length is also 1 over radical 2, then that will be our y value. Now, notice that your sine and cosine are 1 over radical 2, and these two numbers are 1 over radical 2. That is not a coincidence, okay? Because the hypotenuse is 1, and the sine function is opposite over hypotenuse, then this is always going to be just the sine function, all right? It's always going to be the sine. And this is always going to be the cosine. Okay? So the x value is always going to be the cosine function. And the y value is always going to be the sine. Okay, I'll just say cosine theta, sine theta. So anytime you want the coordinates of a point on the unit circle, just understand that the coordinates will always be of the form cosine, comma, sine, every single time. Anyway, back to the real point of the video, which is finding the trig functions of all of these. Now, so we have the three primary trig functions, but what about the reciprocal trig functions? We know that cosecant is just the reciprocal of the sine function. All right, so the reciprocal of this is going to be radical 2. Now, sometimes we make a mistake when students are first learning and they think that cosecant and cosine would be reciprocals because they both start with cos. But no, in fact, sine is the reciprocal of cosecant. And secant is the reciprocal of cosine. Okay, so that would also be radical 2. Now, the reciprocal of tangent is called cotangent. And the reciprocal of 1 is still 1. So there's all 6 trig functions. Okay, so we just looked at what we used to think of as 45 degrees, and we found the trig functions for pi over 4. Now, the next one we want to explore is the one that we used to call 30 degrees. Now, 30 degrees is what you would get if you took one quadrant and you split it up equally into 3 parts. So let's do that. Okay, so if we have this split up equally into 3 parts, then this should be 30 degrees, 30 degrees, and 30 degrees for a total of 90. All right, but we want to talk about this in radians, so we're not going to talk about 30 degrees. So how big is this angle in radians? Well, remember, this semicircle here is 1 whole pi. So if we split up both of these quadrants into 3 parts each, and then of course we have a total of 1, 2, 3, 4, 5, 6 pieces. So each one of these is 1/6 of the pi, or pi over 6. Okay, so now let's find the sine, cosine, and tangent of this guy. Alright, so let me drop this down until it is pi over 6 degrees as our angle right here. So, still the hypotenuse is going to be 1. Now, let's use our knowledge of special triangles to find the rest. Now, what we know is the short side of the triangle is always half the hypotenuse. Okay, that's what we learned. The short side over here is going to be half of this. Well, half of 1 is simply 1/2. Okay, that's half. And then the long leg is the short leg times radical 3. So this leg should be 1/2 radical 3. Now 1/2 radical 3 is the same thing as radical 3 over 2. You know, if you sort of put a 1 under this, and so 1 times radical 3, 2 times 1, we will write this as radical 3 over 2. Okay, so now let's talk sine, cosine, and tangent. So let's see, sine of pi over 6, opposite over hypotenuse. Okay, so that's just going to be 1/2. Cosine of pi over 6 is going to be adjacent over hypotenuse, so that'll just be radical 3 over 2. Now tangent of pi over 6 is going to be opposite over adjacent, so it's going to be 1/2 divided by radical 3 over 2. Now I'm going to do that off to the side and then mention the shortcut. So 1/2 divided by radical 3 over 2. But to divide fractions, you would multiply by the reciprocal. Okay, so 2 over radical 3. Then the 2's cancel out, and you're just left with 1 over radical 3. Okay, now the shortcut is, wait, I said radical 3, but I just put 3. Okay, 1 over radical 3. Now here's the shortcut. All right, we were saying that the tangent of pi over 6 was going to be opposite over adjacent leg. So we were thinking 1/2 over radical 3 over 2. Now when the denominators are the same like this, the shortcut is they are always going to end up canceling out. So this denominator of 2 and this denominator of 2 is going to wind up canceling out. So that's just going to leave you with that 1 over radical 3 that you see here. So if you think of it this way, you can do it in your head. So now let's do the 3 reciprocal trig functions. So the reciprocal of sine is cosecant. So the cosecant of pi over 6 will be 2. All right, the reciprocal of that. Reciprocal of cosine is the secant function. So the secant of pi over 6 is going to equal 2 over radical 3. And then the tangent of pi over 6 is going to be the reciprocal of this, and the reciprocal of that will just be radical 3. All right? By the way, if we ever needed the coordinates of this point right here, again, please remember that the coordinates are going to be cosine, comma, sine. So this would be cosine pi over 6, comma, sine of pi over 6. Okay, so the coordinates of this point are radical 3 over 2, comma, 1/2. All right, that's good to know. All right, another thing to notice is about tangent. Notice that when we did the tangent and we were doing opposite over adjacent, okay, so we were doing 1/2 over radical 3 over 2. Please understand that this 1/2, okay, was the sine function, all right? So that was sine pi over 6. And this radical 3 over 2 was the cosine function. Okay, so that was cosine pi over 6. So what I need you to understand is that tangent of an angle, in fact, let me just put theta in here because it's really general. The tangent of an angle is always equal to the sine of an angle divided by the cosine of an angle. Okay? this is going to come up over and over and over again. So memorize this fact. All right, tangent is sine over cosine. All right, now it's time to evaluate trig functions at our next special angle, what we used to call 60 degrees. All right, we did 30, now we're doing 60. But let's see how many radians that is. Now again, remember that the semicircle is pi radians. So let's imagine that we divided up that pi up into 3 equal parts. To make it more obvious, I'm just going to take out the y-axis for a second. Now, we used to call this 180 degrees. So hopefully you can see that if I split that up 3 ways, that would be 60, 60, and 60. All right, 3 times 6 is 18, 3 times 60 is 180. Now, in terms of radians, though, this is 1/3. Each one of these is 1/3 of the pi. So 60 degrees is the same thing as pi over 3. Okay, so that's our angle. That was a horrible theta. Let me try that again. So this reference angle is pi over 3. Now, to find the values of the trig functions, let's put a triangle, make a triangle out of it, and see what we've got. Okay, so if we make the triangle out of it, hold on. Okay, that's pretty good. If we make the triangle out of it, the thing is, remember that this is 60 degrees, right? So this is like 30 degrees. So once again, we have a 30, 60, 90 triangle. The hypotenuse, of course, is still 1 because it's the radius, is a unit circle, so it's going to be 1. Now, we already did this on the previous triangle, was also a 30, 60, 90 triangle. So I'm not going to redo all the calculations. I'll just remind you that the short leg was 1/2. Just instead of it being vertical, now it's horizontal. The long leg came out to be radical 3 over 2. It used to be horizontal, now it's vertical. Okay, so when we talk about the sine, cosine, and tangent, all right, the sine is opposite over hypotenuse, so that's going to be radical 3 over 2. The cosine is adjacent over hypotenuse, so that's going to be 1/2. All right, these are the same numbers that we had for pi over 6, but the sine and cosine are reversed. Now the tangent of pi over 3. Now, instead of looking at the triangle and going opposite over adjacent, let's remember that we learned a moment ago that tangent is the same thing as sine over cosine. So let's just do that. Let's just look right here. We don't have to go back to the triangle. Let's just use our sine and our cosine. So sine over cosine, all right, and we also learned the shortcut that if the denominators are the same like this, they're going to wind up canceling out. So it's really going to be, when I say sine over cosine, it's going to wind up being radical 3 over 1. All right, and of course we're just going to write that as radical 3. Okay, so that's really the best way to start thinking about it. Now let's do the reciprocal trig functions. So the reciprocal of sine is called cosecant. All right, so cosecant of pi over 3 will be the reciprocal of this. So that'll be 2 over radical 3. And the reciprocal of cosine is the secant function. So that'll be 2 over 1, which is just 2. And the reciprocal of tangent is called cotangent. So the reciprocal of this is going to be 1 over radical 3. So there we have all 6. Alright, our last special angle is the angle that we used to call 90 degrees. Alright, but of course that angle is pi over 2. Pi is the semicircle, and so 90 degrees is halfway, so that's pi divided by 2. Now, we cannot make a triangle like we did on the other problems, alright, because it's just a vertical line. There's no way to make a triangle out of it. That's going to help us. So what we need to do is use one of the things that we learned as we were doing the other ones when we did have a triangle. We learned that the coordinates of the point on the unit circle are going to be always in the form cosine, comma, sine. Okay, where this is the angle. So, for example, when we knew, when we explored pi over 6, okay, why is my writing so horrible today? I said when we explored pi over 6 as our angle, triangle-wise, we figured out that this was going to be 1/2, and this was going to be radical 3 over 2. So that meant that the coordinates of this point would be radical 3 over 2, comma 1/2. But that was the cosine, and this was the sine. Okay, so we can use this fact that the coordinates are the cosine and the sine in order to find the cosine and the sine of a 90-degree angle, because we know what the coordinates are very easily for a 90-degree angle. Remember, this is a unit circle, so this height right here is a height of 1. That means the coordinates of this point on the unit circle will be 0, 1. So remember that the x-coordinate is going to be the cosine of the angle, and the y-coordinate is going to be the sine of the angle. So that means we've got it. The sine of pi over 2 is 1. The cosine of pi over 2 is 0. Now, the tangent of pi over 2. Again, let's use what we have learned. We learned that tangent is the same thing as sine over cosine. Okay, now the sine and the cosine are 1 and 0. Okay, so the tangent is going to be 1 over 0. So it's just a matter of what's the value of this? Well, that's undefined, isn't it? You can't divide by 0. Don't be crazy. So the tangent of pi over 2 is undefined. Okay. So let's talk about the reciprocal trig functions. So the reciprocal of sine is going to be the cosecant function. So cosecant of pi over 2. All right. Now the reciprocal of 1 is just 1. Okay, so there you go. Now the reciprocal of the cosine function is a little trickier. We're talking about the secant function, so the secant of pi over 2. All right, but 0. You can think of 0 as like 0 over 1. Okay, so when you go to do the reciprocal of that, that would be like having 1 over 0. So that is going to be undefined. Okay, I guess another way to think about it is the reciprocal is like taking whatever you've got and putting a 1 over it. So 1 over 0 is undefined. Alright, now how about the reciprocal of the tangent function? Okay, so we are talking about the cotangent function. So because the cotangent is the reciprocal of the tangent function. Now, it's tricky to look at undefined and think about what the reciprocal of undefined is. So what I'd prefer to do is go back to what we know about tangent. Okay, tangent is sine over cosine. We've learned this. We have proven this. So if we want to do cotangent of any angle, it'll be the reciprocal. So that means cotangent will be cosine over sine. So if you look at it that way, it's easy to understand. We'll just do cosine over sine. 0 over 1 is 0. Okay? So, as a shortcut, when you have 0, the reciprocal is going to be undefined. When you have undefined, the reciprocal trig function is going to be 0. So there you have it. That's all of the special angles. Alright, let's zoom out and look at all of the values of the special angles that we have just studied. We learned about the 6 trig function values of pi over 4, and it came out to be this. And we did pi over 6, which was like 30 degrees, and we did pi over 3, and that was like 60 degrees, and we did pi over 2, which was like 90 degrees, and pi over 4 was our 45 degrees. Okay, in the next video, we're going to look at, it took us 25 minutes to go through all this. You do not want to have to do all these things with triangles and special triangles to find these values. We're going to need a way to immediately get these values very quickly. So it's really going to boil down to a little bit of memorization and then looking at patterns. So in the next video, we're going to learn how to get all of this information really from 3 facts. Okay? And spoiler alert, the 3 facts are going to be, no, not that one. Well, sort of. We can get it from the sine of pi over 4 and the sine and cosine of pi over 6. If you memorize these 3 facts and a few patterns, you can get everything else from these 3 facts. And that's what we're going to learn on the next video. So immediately go watch the next video. I'll meet you over there.